We're starting chapter 11 here, and 11.1 is about sequences. So a sequence is just an ordered list of numbers, and we denote them some of the time with these braces. Sometimes we wind up just writing them out, but formally we put braces around the sequence. And the different pieces here are called terms. So A1 is the first term, and we can denote it like this by putting A sub n or a formula for A sub n inside of the curly braces. And sometimes we'll put this over here. This n equals 0, that's a subscript that tells you where to start. And up top, this tells you where to stop. Or maybe a better thing would be to say how high to go, because if it's infinity, you don't really stop. But if these aren't given to you, then they're usually apparent by context. Um, most of the sequences that we deal with are going to be infinite in length, so this is almost always going to be infinity. And the starting point is usually going to be 0 or 1, but sometimes it'll be specified to be 2 or some other number, because usually that's because plugging in n equals 0 or 1 causes some kind of problem. So let's look at a couple of examples. Right here we've got 2n, or 2 raised to the n, going from 0 to infinity. So if we wanted to write this out as a list of terms, the first one would be we plug in n equals 0, and that would give us 2 to the 0, which is 1. Then we do n equals 1, then n equals 2, and so on. So this next one would be 2, then 2 to the second is 4, 8, 16, etc. All right, this next one down here, it doesn't tell us where to start or stop, but we know that it means infinity. Yeah, it go forever. And for a starting point, we could pick 0 or 1. So 1 squared, 2 squared, 3 squared, 4 squared, etc. Now, yeah, it's a bit ambiguous, because do we start at 0 or 1? Well, if that's important, I'll specify to you. But usually we're more interested in what happens to the series, or I'm sorry, the sequence, as n gets big. So if there's not a starting point, if it's important, I'll tell you where to start. If it's not important, then it's not important. All right. A sequence can be thought of as a function with its domain restricted to the non-negative integers. And that makes good sense up here. It's like we're plugging in 1, 2, 3, 4, n for n. And an alternating sequence is one that changes sign every term. So I've got 3 examples here. This one is an alternating sequence because it alternates between positive and negative. This next one, this would be the sequence where, let's see, if we start with n equals 1, then we get negative 1 to the first power over 2 to the first. So that's going to be negative 1/2. And then when n equals 2, on the bottom we'd get 2 squared, which is 4. And on top we get negative 1 squared, which is positive 1. But as we keep going, every time we go to the next term, the sign is going to change, and the bottom is going to double. Like that. Now look at this one. These 2 sequences, this one and this one, the only difference is the power on n here. So if we start writing this one out, starting at n equals 1, what do we get? We get negative 1 to the second power up here, so we get 1/2. Then we get negative 1/4, positive 1/8, negative 1/16. So I'm just writing these out because I'm not really explaining how I'm getting it, but I think it's apparent. If you plug in 2 here, notice what you get on the bottom. You get 2 squared, and on the top you get negative 1 to the third power, and of course negative to the third power gives you a negative. So basically these are this is like the typical way to make the terms alternate. And putting a +1 or a -1 would work too. But putting that lets you shift whether the first term is positive or the first term is negative. Now, one thing to be careful about is, in order to be considered an alternating sequence, the sign has to change every single term. So something like this, where sort of the pattern here is we've got a positive, two negatives, a positive, two negatives, positive, two negatives, and so on. That's not an alternating sequence because it doesn't change every single time. Another place where you'll run into something that's not an alternating sequence but might kind of look like it is if you did something like a sub n is sine of n, where n is in radians. If you do that, then the sign is going to change, but it's not going to change every single time. So this is not alternating. All right, let's graph this sequence now. We've got the sequence a sub n equals -1 to the n over 2 to the n. Now, I want to start this one at 0. So when n equals 0, I'll tell you what I'm going to do. I'm just going to put n up here, 0, 1, 2, 3. And our a sub n is going to be, let's see, this is going to be 1, because anything to the 0 is 1. When n is 1, we get -1 on top and 2 on bottom. When n is 2, we get +1 on top and 4 on the bottom. And when you graph a sequence, it's like graphing a function, but instead of graphing like a smooth curve, you just graph the points. So at 0, we're going to have this point up here at 1. At 1, we're going to have -1/2. Now let's see, each one of these, 1, 2, all right, each one of these dots is 1/4. So over here at 1, we're going to go down to -1/2. Then at 2, we're going to be at 1/4. At 3, we're going to be at 1/8. At 4, we're going to be at 1/16. So notice what's happening here. Every time we go to the next term, from one to the next, we switch between positive and negative, and the distance from the point to the line, to the axis, cuts in half every time. So if you think about what's happening to this, when n grows large, the points get really close to the axis. So we'd say that this sequence converges to 0. And what that means is we can get it as close to 0 as we want by taking n to be as sufficiently large. So we need to talk more about sequence convergence and divergence, but let's put that in the next video.